In the example here, we need to write program to perform this milling operation and drilling operation. Milling operation, we're using this tool number 1, and drilling operation with using the tool number 2. And here you are provided with some information about the tools, which is like diameter for the tool, and also information about the speed and feed rate. We see how we define first the coordinates for each point here from point 1 until we end or at point 9 here. So and return again to point number 12. We see we need to consider the diameter of the tools when we calculate these points. And here in the slide, we already see how we can calculate the extra coordinates or distance in each axis. Either in the x-axis, we call it delta x, and in the y-axis, we call it delta y. So this extra distance is generated by due to the movement or due to the diameter of the tools. Okay, so this delta x and delta y will be changed if the diameter of your tool will change. So because it totally depends on the radius of the tool and also the angle of the milling. Okay, how the tool will move from one point to another point. And this you can define or you can find from your, from the provided diagram. So here, after we define all the point coordinates until the last point, then we start to write the program. And we said usually the CNC program or NC program here consists from 3 main parts. The first is, we call it the setup part. And in this setup part, we are going to highlight the program name and write some comments about the program to define what this program will do. So all information between bracket here will be like comments and will not be executed. The first line here is the program number. It will be saved, and later on we can call this program by its number. But the rest 3 lines here between bracket, as you can see here, this bracket here, that means whatever you write here, it will be appear only in the program. So the user later on, or the one who will use the machine, he can read what the information that you provide here. Tool 1 information, tool 2 information, and so on, all this between bracket. So we said when you put this information between bracket, that means it's become like comments and it will not be executed or give you error in the program. For the CNC program, it's important to know the meaning of the code. So on the left side, you are going to write the code. On the right side, you are going to define the meaning. And you may see such example or such question in the exam or in the test. Okay, in the quiz or in the quiz. So you are required to write here definitions. Maybe you will be provided with the code. I ask you to give the meaning, or you will be provided by the meaning or the explanation in description. Then you are required to write the code. So for example, here we start here for machine start up. So here the machine start up sequence start from the definition for the coordinates. I mean the definition of the standard of measurements. Is it in inch or in millimeter? Is it absolute or incremental? Are you going to use any drilling cycle and so on? So all this information will be divided or will be written in the first part. The machine startup operation. So as you can see here, this is the number of line, then N0010, N0020, N0030, and so on. And this, if you don't write, it's okay. But why we need to write this one? Because sometimes if you have error, it's easy to follow. Easy to go back to line number 10, easy to go back to line number 30, and so on. So here, for example, you define in the beginning, you need, because our program here is only linear. Linear, that means the code that or the G code that you are going to use here for performing the operation will be the G1. Okay, you may need G0, but G1, but you don't need to use G02 or G03 because we do not have any circular profile. So only linear. But other parameters there are related to the setting or to the startup of the machines. So for example, here we have G90, we have G20, we have G40, we have G80. All will be defined here. This will be for absolute in inch mode. cancel cutter diameter compensation. That means the cutter diameter will be not compensate. Then we are going to use a fixed, also, I mean, the cancel for the fixed cycles. Okay. So then we are going to return again. I mean, we need to define reference point, because as you can see here in the original figure here, this is our reference point. There is a reference point for the machine and reference point for the part. So in the beginning, the machine will be, or the spindle will be at the machine reference point. Then you need to move it to the reference point of the part, which is the at start point here to start to the milling operation. So first, it will return to the original reference point, which is 1. Then you are going to preset absolute 0 point here. So you are going to define the point, which is x negative 10 and y equal to 5 and z equal to 0. So here it's in absolute, and you are going to define it like 0 point, I mean the reference point. After that, you are going to select the tools, because we have 2 tools. So we need to select first the tool for cutting. The second tool is for milling. Later on, we will see how we can simulate such or how we can run such program. Then you select the tool number 1. The tool number 1 already defined here with this information, which is 0.5 diameter and 0.75 deep, and it is mill contour. So it's not for drilling, it's for milling. And here just this comment here, finish contour as per print. That means you are going to mill the shape as it is provided in the graph, like this one, then go down, then return before you move to the drilling process. So just first focus is more, or the first part of the program will focus more on the milling part, or the contour milling. Then you go rapid movement. We said G0 here will move the spindle to the specific point to start to move. So here the spindle will move from point number 1 to point number 2, as we already mentioned before when we talk. This is reference point. Now it will move without any operation in between 1 and 2, because the part is still there. So when the spindle move from point 1 to point 2, just move, fast move. Until now, we didn't start our milling process. For that, we do not have G0, G1 here, only G0. Then G90, this is to, I mean, to define the absolute. Then actually for G90 and G91, you can change. I mean, in every place or in any place in your code, you may change. I mean, if you feel here, it's better to use for incremental, so you can change to incremental. If you feel it's better to follow by using the absolute, you just using the absolute or continue using absolute form. Then you move to this point, which is point number 2, which is negative 35.25, and the z is equal to 0, which is on the top of the workpiece. And then at the speed of 1000 here, start spindle 1000 RPM clockwise. Okay, so you select to run the spindle at the speed of 1000 in the direction of clockwise. Then go 34 Z1 H1 here, rapid move to the tool 1 to the point 1 above the bar. That means this, you are now at point 2, but you want to go closer to the part on the top of the bar to start the operation of milling. So the machine will, or the spindle will move at the z equal to 0.1 on the top of the part. And 70M here, you are going to, or the machine will make the coolant on, and this more related to that. I mean, need more understanding about when we need to do cooling to decrease the temperature of the material and to avoid the broken of the spindle tool. So usually when they change the machine, I mean the tool, they need to have this coolant on first. Then at the end of this cycle, they are going to make coolant off. So from this point here, we start with the profile operation sequence. So we start to see G1 here. Previously, no G1 until here, until this point, all like start up, but you did not start the operation yet. Just prepare, make the cutter, make the tool closer to the part and so on until the tool or the spider become close to the part. Now we are going to give the command to start the cutting process. So cutting, that means we are going to use the linear because we have here line, here another line, here another line, line. So all straight lines. So we are going to the linear profile. So rapid move here, and we define what is the value of the Z here, because we need to know for which depth the Z will go or need to cut, or to define the feed rate here. So if the Z is 0 or the Z is 0.1, that means the tool will stay on top of the part. It's not go inside the part to cut the part or to make or to go for milling of the part. So for this one, Z is negative 0.4. That means it will go in the depth of 0.4 at the feed rate of 6. So we define the value of the feed rate here, which is 6. That means to cut or to mill the part. Then from this point here until the point number 7, until this point, the machine or the cutting machine will move from one coordinate to another coordinate. As you can see here, so first, starting from this point, okay, it will move to the second coordinate at point number 3, then move at the second coordinate at point number 4, go down until point number 5, return until point number 6, return until point number 7. That means it will make like complete cycle for cutting this part after we already define all these coordinates. So it's easy for the tools to move from one coordinate to the other coordinates. So it will use the order G01. So this G01 will make the cut of this part in this shape according to this sequence. We do not start yet to do the second operation, which is the drilling process, just the cutting process. So after we reach to point number 7 here, cut x negative 0.2y, x negative 0.25, y 0.25. This will be the point 7 here. Then go rapid move above the part. Why we need to go up? Because after you finish the cutting, the spindle should go away from the part. Otherwise, it will retain the cutting process. It will crash with the body maybe. Okay. So after you finish the cutting, so you need to return to G0 here. Go fast with the absolute coordinate to the Z1 and M5. So need to take the spindle up at the point number 7. The spindle will go up and stop the cutting process. That means it will go away from the cutting from the work piece here. Then coolant off, because we are going to use another tool here. Now we already finished the first operation, which is the cutting. So now we are going to apply that drilling tool. So this is the machine startup for the sequence number 2. So the machine needs to start to change to the sequence number 2 or to the tool operation number 2 here. So rapid move to YZ reference point, which is number 8. This is the reference point for the second reference point for the spindle here to the tool the change position. So we move from 7 with with G0, just move fast traverse from 7 to 8, and at this point we are going to make tool change position. So at point 8, the tools will be changed from tool number 1, which is the profile mill contour, into the drill tool. So what, as we said, there is inside the machine, there is automatic tool changer. So this automatic tool changer will be responsible to change the tool based on their number. If you say T1, it gives you tool number 1. If you say T2, it will give you tool number 2. Usually there is some embedded tools inside the machines, so you need to and with their sequence number. So during the programming, you just need to select the correct tools which you require for your operation based on the given information here. So after it reached to this point here, we are going to change the tool by using the order or the command T2 M6 here to change the tool to number 2, and here just command to define what with tool number 2 is. It's used for drilling hole, and we are going to use to create hole by using this tool, which is with this specific diameter with this specific depth. Then rapid move to 0.9. This 0.9 is the first point of our drill. So this is 0.9. Now it's the reference point of changing the tool is 8. Now I want the spindle to move to 0.9. So I'm going to give the coordinates for 0.9. So the coordinate of 0.9 with the command here of the G0. So rapid move to 0.9 with absolute coordinate here. And you define the coordinate for 0.9, which is x 0.5, y negative 0.5, and z is equal to 0. 0, that means exactly at the top of the workpiece. Because usually we say the reference of the workpiece used on the top, on the left top side, for example. So the z here, the Z is 0 on the top of the workpiece. If you go inside the workpiece, that means you want to make a drill or you want to make a hole. So in this case, you are going to enter the coordinates of Z in the negative, because it's like it's on the top, I mean on the top of the workpiece. So this is the 0 of Z. If you go inside, that means you are going to move from the positive side of Z into the negative side of the Z. So at this point, you are going to start the spindle at speed 1,500 according to the given information in the table, clockwise here. Then you go to rapid move for tool 2 here in the above part. That means you are going to move it too close to the reference point, which is 0.1. I mean, it's like in standby position before start the drilling operation. And we see in the when we talk about the drill operation for when we talk about the drill cycle before, when I talk about the GET, GET1, and GET2. Then the coolant is on here before we start the operation here of the drilling. Then the spindle will start to move. I mean, when we use the GT83 here for the drill cycle at the point number 9. So when we define the cycle for drill here, we already at this position, which is point number 9, it will create the hole at this coordinate, which is x 0.5, x negative 5, z. This will be the depth, negative 0.515. So that means the hole will be until the depth of negative 0.515 of z. Then here R is the reference point. R is the reference point. As we mentioned before, when we talk about the drilling cycle, we said we need to define the position of R and also the Q here. And here is the feed rate of the, what is the feed rate. After it performed the drill, it will return back to the drill go down, make the hole, then go up again. Because in order to move from the one hole to another hole, cannot move while the drill inside the workpiece. So need the drill go out, then move to the second position, go down, make the second hole, go out, up, and then move to the third position to make the second hole, and so on. So no need to no need to to redefine the drill cycle again in all this one. No, we already have it one, so just make drill at node number 9, then again go define the second position, which is at 10, at 11, and it will make the drill at this point 10 and point 11. Then the drill cycle will be off or fixed. Okay, cancel any fixed cycle here. J38 is cancelled because we use it to create the 3 holes. According to this figure here, we need to create hole at point 9, hole at point 10, and hole at point 11. Then we need to cancel this cycle, which is the drill J83, by using the command, which is J80. You can refer back to the table to check out or to check again or to confirm what is every command here means. After we finish this one, so we stop the drilling cycle here. Now we are going to rapid move to the above part. I mean, it will go up from the point here at the point 11. It will go up until z equal to 1. That means it will go away from, if this is the workpiece, and the spindle will stop at this point, for example, after at 1 millimeter away from the workpiece. Okay, then it will move. The spindle here will stop, and it will move again, and the coolant will be off. Then it will return back to the reference point, which is the point 12 here. So as you can see, after we create the 11 here, we create the cycle, I mean the hole at 11, it will return back directly to the reference point at the point 12. This means you already do the cutting process, and after finishing the cutting process, it's done the holes at 9, at 10, at 11, then it back to the reference point of the machine reference point. Okay, is it clear here? I will give you some time later on to download one software just to see how this code working. Okay, so just I want to continue with the circular profile here. Then later on we are going to see how this can be worked. What? Okay, for the circular profile, actually this already talk also, but as I told you before, when we talk about the linear profile, we do not have such complete program to perform a task. We only have one line code, which is G1 at this coordinate, just to show you how the format of the linear profile will be applied for one block or one address. But here in this chapter, we are going to see this command in a complete program. That means you can take this code and you use it with some simulator or some CNC machine, so it will perform the same task. It will create the same shape here, same like this one. I mean, if you take this code, you enter to a real or I mean to a real CNC machine, and you provide it with some workpiece, whatever is the workpiece dimensions, actually it should be greater than this piece. So it will cut this workpiece in this shape according to the entering commands in this program. So what I want you to understand here now, or to come out, you need to understand how we can define the different part of the program and how we can translate this code into text or into explanation here. Each code, what each code can do, or why we need this block, why we need that block, why we need that block, and so on. Now for the programming circular profile here, when we talk about the circular profile, we are talking about not the move in straight line. No, we will have some round at the end. For example, we have round, this round based on a defined diameter or a defined radius and so on. So usually for the circular profile, we use, as we said before, we use G2 and G3. G2 for clockwise and G3 for counterclockwise. So if you have you want to make a round, I mean, you want to make round in this direction. So for example, you are going to use G2. If you want it in other direction, so you are going, I mean, the movement from the start point to the end point of the arc. So from start point to the end point, is it clockwise or counterclockwise? So this way we are going to use G2 or G3. What there are some of the operation which should be executed when you are going to use G2 or G3. So I mean you have to use G17, 18, 19 to define the plane. This we already mentioned before. We said for counterclockwise, I mean for the counterclockwise or clockwise circular profile, we need to define which plane we are working on. Is it XY? Is it XZ? Is it YZ? Okay, so you need to define if each plane you are working with. Then the tool positioning arc, start point and end, because in the case of the linear profile we need to define the coordinates of the first point and the end point, even we are going in straight line. But in the case of the arc here, we need to define the first or the start point and the end point of the arc. We need also to know the radius of the arc or the diameter of the arc, the fit rate, and also the absolute or incremental coordinates. All these need to be defined in the program. We have this example here. So we need to perform the cutting here from start point, from this point, starting from this point here, and go in this line, go directly here until this point. Then we have circular profile at this point, this circular profile, and here at the end of this point. So this is the initial position of the circular profile. This one is the end position of the circular profile. So you have in the beginning G1. So this G1 here will give you the linear profiling until this point. Then from this point to that point, we are going to use G2 because it is clockwise. See, you can see the direction here is clockwise. So we are going to use G2 commands. And we need to define the coordinates for these 2 points, the start point and the end point. Sometimes you will not be given the values as a value, so you will be given such drawings. So you need to do some calculations in order to define the coordinates, because the coordinates is the main part for the CNC program. So at this point, for example, here you need to define the first point or the start point. Then you need to define what is the coordinate of that point. Then you need to define what is the coordinate of that point. So for the first point here, or for the first move from the reference point, we need to move until here, which is x equal to 3 and y is equal to 0.25. Okay, so in this x-axis here, the G1 will move from x to 3 and y 0.25. Why y 0.25 here? And the feed rate is equal to 10. That means this is to define the movement from this point. If this is the 0 point and the diameter is 0.5, I mean the diameter of this circle is 0.5, so the radius is 0.25. That means this axis or this center here will be at 0.25 of y. So it will move to this point, which is 0.25. Okay, since the diameter is 0.5, half of it is 0.25. So this is the coordinate for the point y. For the point x already given here, which is equal to 3. So this is the first line of the code. Then when we go to the second line, we need to define the program circular profile here. So the program circular profile we already see before how we define. We define by using the coordinate of the start point, start point and end point, and also we need to define either I or J. And we said I and J is how or what is the different, where is the point here from the center of the arc. This is the center of the arc. How many in the x, or what is the distance for I? I represent the distance from the start point in the x-axis, and J represent the distance from the start point in the y-axis. So if the spindle is stopped at this point and I want it to move to the second point, which is here, so that means I need to define what is the value here, what is the coordinate of this value. This point I already know. We said it is 3 and it is y 0.25, but what is the coordinate for this point? So you need to perform some calculation here to find what is the coordinate for this point. This point is x, but what is the value of x here? We don't know what is the value of x. We need to calculate the value of x. So x until here it is 3, but at this point it's not defined. This part of the triangle here, we don't know what is the value. So you have triangle, this right angle triangle here, and you have like this one. Okay, if you want to find, if we say this is delta x, because it is changed in the delta, and this is delta y, so this is changed in the, I mean, this is in the x-axis, this is in the y-axis. So this line and this line, we don't know. So this represents the add-on values that you need to add to x-axis and to y-axis in order to know what is the value here. So this is why until this point here, I mean, until this point, y is equal to 2. Until here, y is equal to 2, but we don't know what is the rest here. What is the length of this line? For x, until here we have 3, we don't know what is the rest of this line. So we need to do some calculation based on this angle here that you have, 60. So from the 60 angle, you can find cosine 60, which is delta x over, I mean, adjacent over hypotenuse here. So you are going to calculate this value. This line already know it is 2.25 because this 2.25 represent the diameter, which is 2 plus the 0.25 from the radius of the tool. This line, I mean this until this point here, you can see until here it's 0.2, but plus the radius of the tool, which is 0.25 because it's here, radius is here. This is 2 and 0.25 represent the radius of the tool. Okay, so this line is 2.25 and this angle is 60. I can find what is the value of this line and also what is the value of that line. So in this case here, we have the value of x is equal to 4.125. That means the line here is 1.125 based on the calculation of this angle here, cosine of this angle, and the length of this line is equal to negative 1.94 because we have here 2, so it will be negative 1.94, this line here, based on, because this is sine of this 60, you can calculate sine and cosine formula here. So we define these two values, and now what is the, I mean, from the start point to the x, it is 0 because it's not movement from the start point to the x on the x-axis. Our movement will be only on the y-axis, which is negative 2.25. So this program, if you write or if you enter to the machine, it will create this type of milling, which consists from linear profile and circular profile. This we use when we use the G90. If we want to use this another example here, when we use incremental, and in the same way here, this is the 0 point, and we want the tool to move from this start point, for example, from this point until here. This will be linear. So linear here will be move linear for 1.5x at speed. On y there is no movement because it starts already here. We're not talking about the 0, 1 here. We start from this one until this one incremental. So the incremental here will be on the, we are using G91. So the movement will be only on the x-axis, no movement on the y-axis. So we use just 1.5 at speed rate, the feed rate is equal to 6. Then it will move from this point until the second point, start point until the second point here. Also by using the, when we're using the incremental coordinate, that means it will move from this point to that point. You need to find what is the coordinates in the incremental coordinate for this value. So again, you need to calculate what is the value of x here based on the cosine of this angle. So cosine 60, from cosine 60, you know what is the value of the hypotenuse here. So you can find what is the value of this line and what is the value of that line. So you can write the comment for these coordinates. So this is about the program profile. Another example here, we can see the same. Any question until here? You still there or not? There is one student there or not?
Yes.
Yes, sir.
Okay, so for this circular interpolation here, also the same, clockwise and counterclockwise. You come to this point, then go again here, and this using the set. I mean the circular profiling. The first is linear profiling, then the circular profiling, then linear again, then return back again. So only this part will be circular profiling that we need to consider the value of R. So as you can see here, the first of your program, you need to write here the G01. So here we are going to perform a milling by using, as you can see here, end mill. So this is the type of the tool with the diameter of 0.5. So the diameter here is, I mean, the radius will be 0.25. So the movement of the tool will be from this point, which is the initial point here, x equal to 0, y 0, and feed rate is equal to 12. To from the part of the origin here, as you can see here, this is the origin point. This point here, and we start from this point. So this is the 0 point of the part. Then G01, X0, Y1, that means the movement here will not be, I mean, this movement from here go from 0x equal to 0, and it will go in the y direction only. So it will go up for y direction. Start from the 0 point, go up from the y direction by the value of 1. So this the value of x equal to 0, y equal to 1. Then until reach to this point, then it will go again on the x-axis, and the y is start to 1. So G01, x equal to 1.5, y equal to 1, which is the point is here. X equal to 1.5. This is x equal to 2, but minus the point, I mean, here we are going to move, or the spider will move from until G01, I mean G01, x 1.5, y equal 1 to start point of the arc here. At the border here, before to change from linear profiling into circular profiling clockwise. Then you need to define for the circular part here, which is the end point of the circular point. So we use the circular profile, which is G02, x equal to 2, and y equal to 0.5. So y equal to 0.5, it depends, because if this total y is 1, so that means the half here at this point, which is depend on this one, is 0.5 here, 0.25. So the point is based on the value of the R, which is 0.5. This is to the end of the point of the arc. Then again, it will convert to linear profile to the point 2 and 0, which is here, until this point. Then from this point, again, it will return to the original point, which is 0 and 0. Actually, usually for the milling process here, you just or the spindle will move around or along the drawing path in order to perform cutting or make a slot or make I mean remove some part of the border of this workpiece. So here it will move from this point along this line. You need to define the coordinates, then go again. And when you define the coordinate, you need to consider the radius of the arc and also the diameter of the tool. So this all we need to consider when you do the calculation for the coordinate. If you have the correct coordinates, so you are going to generate the correct figure. If you have wrong coordinates, that means you will not be able to generate this figure. Because if I give wrong coordinates, maybe it will cut from this point, maybe the spindle will be away from the part itself. Maybe the spindle will work on the table only, not on the workpiece that is placed in a specific dimension. So The dimension of the workpiece that you are working on is very important in order to know, or in order to develop the program for a specific path. Same here, but here is counterclockwise. So counterclockwise, that means the machine will, or the direction of the movement for the spindle will be counterclockwise, not clockwise. So this is the movement, as you can see here, until this point. It's counterclockwise, starting from this point, move from the beginning of this. So G01, X0, Y0, F12. This is the part of the origin that we have in the 0 point. Then the machine need to move linear line for X 2.5, Y equal to 0. That means in the Y direction it's will be 0, and in the X direction will be 2.5. G03, G01, and so on. All these just mixed between the command for linear. These all linears. Then you come to the part which is clockwise, starting from this part until here. This is the only bar that you have will be circular profile. Then the rest will be linear profile. You can revise how we got these coordinates for each point until we reach to the X0, Y0, or return to the original point. Okay, I will stop here for the slides. Okay, now I want you to open this link and download this software. We call it CNC simulator. Actually, I share with you like 7 simulators. Some of them like online based, so you no need to develop any or no need to install. You just use it, like this CNC viewer. But actually, this coordinate or this type of simulator will not simulate a real case. It will simulate the path only. So it will show you whatever is the code that you write here. It will show you the path of the spindle here. So the spindle go up, down, and so on. So you can try to check with this type of simulator, like all listed in this simulation tool file that I share with you in Kalam. So you can check, you can try to play with this one to draw simple linear profiling or simple circular profiling and so on. And also later on, when I give you the assignment to you, you are required to use one of these simulators that I list you in Kalam. Okay. The other simulator that I share also, it's also online based. This one, G code, and also there is one simulator which is you can install. But for now, just I want you to download this one. Okay, all they listed in the file that I shared with you previously, and the simulation tool. For now, I want you to download by using this link, just to try is it okay or not. I will share the link here in the chat. Okay. After you download this file, actually it's like 180 megabyte. So you download, then you install. Better you advise to switch off your antivirus just for a while after you before you install. Then you install this software. After you install this software, you are going to run it. After you run, you need to enter your information. So better to use. Actually, this software gives you like 30 days trial version, but it's fully version. That means can use many of its functionalities for free for 30 days. 30 days, that means from now until 22 January, already finished the semester. I think it's enough for you. But if you want to extend later on, in order to use for the lab later for the next sem, for example, and so on, so just use another email. So you have, for each email you will be given 30 days. So you can use register more than one email later on. After you finish the first 30 days, you can install again using different email. After you install, you will see screen. In this screen, they will ask you to enter your name, your organization, your email. As I told you, any of your emails. Then you will run the simulator. It will be like this one. So this is the the interface for the simulator, and as you can see here, it's trial version. So, and if you check here in the setting, you can find your license. For me, for example, it's like 29 days. If you finish, then you will be given another. You can use different type of or different emails. For each email, you will get 30 days. Okay. So try to install now, and later we'll see how to run simple example on such simulator.